Hello everyone, welcome to my YouTube channel. I'm back with another video. Before starting, I would be really grateful if you could subscribe to my YouTube channel and hit the like button and stick around until end of this video. I would be really appreciated if you could share this video with your friend if it is helpful for you. Today I'm going to talk about artificial intelligence and deep learning, and I want to explain how we can predict stress distribution using deep learning and CNN approach. As you know, for obtaining the stress distribution of a part, we have to use finite element method, and we have to do several simulation and perform repetitive task. And sometimes this kind of task could be boring for us, and also it is time consuming task. For that's why we need a alternative task or approach to keep our time and prevent of losing our time and wasting our time. For that's why I'm going to talk about the CNN, and in this video I will explain about the fundamental concept of artificial neural network, deep learning, and also about the CNN method. Okay, let's start first. Let's start with artificial intelligence. As you can see in the picture, generally artificial intelligence is a very broad science or field in the computer science, and it has many application in other fields, and also based on the its application, it can be so simple or so complex, like the AI, which is used in autonomous vehicle, and what the artificial intelligence is. The artificial intelligence, or AI, means creating or intelligence for machine, enabling them to perform the task that human can do. And also what machine learning is. Machine learning is a subset of artificial intelligence and focuses on developing algorithms that enable machine to learn. So we use machine learning method to learn our algorithm, or for learning our algorithm or machine, and it is so important then that we know that the machine learning is a subset of artificial intelligence, not a separate topic. And how about deep learning? Deep learning is a method for improving our model and uses an artificial neural network to reach more accurate conclusion. And also, deep learning is a subset of machine learning. Let's see where we can use or where the AI is used. The AI is usually is used, for example, for so complex tasks like driverless cars, which is trend in nowadays, and or it can be used in medical science, for example, for predicting the lifespan of a human by providing data, and also or it can be used for in chatbot that can answer the human question. Also, about machine learning. Machine learning has a broad application in different uh, fields, and depends on the what we want to do. It can be complex or easy, and also we can use machine learning in for object detection, as you can see in the first picture, and or emotion recognition, or image classification, which is the most one of the most popular methods in AI or machine learning. Or we can use recommender system for online shop. Also, as I already mentioned, it can be used in medical science for example, for cancer diagnosis, or we can use it in navigation like GPS to find the best way, and also in translation system we can use machine learning. And now let's think about artificial intelligence, artificial neural network, and deep learning. What the artificial neural network is and how it works. The artificial neural network is a simplified version of human brain. Neural network in that each neural network is made of several cells. As you can see in the left picture, we each of these circles we call it neuron, and artificial neural networks is made of several these kind of neurons, and these neurons are connected with each other, and in a simple structure of artificial neural network we had three different layer: input layer, hidden layer, and output layer. Which in the hidden layer, our computational task is done in hidden layer. In the past, because of the limitation of computer hardware, and also shortage in data, in providing data for our model, we cannot use a complex model or add a layer to our artificial neural network, because the computers weren't that much strong to calculate the difficult or complex models. As the computer developed and data increased, a new concept is created, or is built, which is known by deep neural network, or deep learning, which we can add or do our task with more than three layer. We can add a layer to our structure, to our simple artificial neural network, and then we increase the layer in artificial neural network, it becomes a deep neural network. And by deep neural network we can do several complex tasks and perform the so complex project that we are not able to do it by simple artificial neural network. As you can see in this picture, in this slide, you can see different categories of machine learning and algorithm of and the most popular algorithm which is used in these categories. For the first one is supervised learning, unsupervised learning, semi-supervised learning, and reinforcement learning. Supervised learning means in this method the behavior of machine or algorithm is closely monitored, and it undergoes training in a supervised manner, and it is divided two different categories: continuous target valuable or categorical. And for continuous data we can use regression model or method, and for categorical we have to use classification model. And for example, for regression we can use for predicting the house price, since the data is continuously. And for classification we can use in this method for medical image training and prediction medical image. And the most algorithm which is used in this method are linear regression, logistic regression, random forest, and neural network. Also, unsupervised learning, unlike the supervised learning, the data which is given to this algorithm doesn't have any label, and the algorithm itself should have understand how should categorize the data. And semi-supervised is a model combining the first and the second one model. And reinforcement learning, in this model, instead of supplying data for model, we placed our model in the related environment, where it gradually learn how should decide for different situation. For example, assume that you are playing a game, and in game, if the for example your player hit with a barrier, you will be game over and failed in that game. And after that, the algorithm learns that learns that must jump from the barrier. And if and the algorithm if the player jump from the barrier, the game gives it, for example, extra credit or extra prize or something like that. In this method we can use it for game or and reinforcement learning can be used for driverless car or other thing. The most important library which we should use in machine learning, and it is used, they are used in machine learning, are TensorFlow, scikit-learn, NumPy, actually NumPy, Matplotlib, Pandas, Seaborn are the libraries of Python. And TensorFlow and Cross is the especially is used for machine learning, and Cross is a subset of actually TensorFlow. And here you can see the model flow of deep learning. For doing the deep learning model, we have to first collect the data, and for collecting data, we need either gather data from, for example, internet, or doing simulation and make our raw data, and then we have to process data, and after processing data, we need to separate the trained data from the test data, and train our model by train data set, and after that test our model and evaluate the accuracy of our model. And if the accuracy is okay and we're satisfied from our model, we can deploy our model. So some question will be there is some question here. What is meaning of the data processing, and what we should do in this stage, and as well as how we can assess or evaluate our model, and how we should obtain the accuracy of our model. For data preparation, we first, as you can see, we have to collect data, and we have to formatting and cleaning the data. It means that we, for example, if we have a picture as a data set, input data set, we have to make all the data set and all picture in the same size and with same resolution, with same size, with same pixel, and then we have to normalizing if our data is for example, and as a numerical data, we should normalizing or standardizing our model, and in terms of degree of importance, we need to do the scaling or normalizing. And after that, after preparing data set stage, we have to train our model, and after training we should assess and evaluate our model by these criteria. These matrix, we call it confusion matrix, which is includes 4 cells. And what is true positive? True positive means the real data or value was positive, and our model predict positive. It is positive, and this is okay and great. What is false negative? False negative means the value was positive, but our model predicts negative, and here we made a mistake, and our model made a mistake, and the error type is type 2. And how about false negative, false positive? False positive means the data and input data or value was negative, but we predict positive, and here we again made a mistake, and this type error is type 1. and true negative means the value was negative and our model predict negative, and this is okay and right and great. And for precision and there are three performance criteria: accuracy, recall, and precision, and we have to define these are in our model, and we can use these criteria, these three criteria, for evaluating our model. And actually accuracy shows how much our model predict correctly, and recall actually show how many percentages our model correctly predict among the positive data. And these are the numerical or formula, the mathematical formula of these criteria. And about deep learning model. Deep learning model consists of input layer and hidden layer and output layer. The number of input layer is dependent on our work, and it could be so vary and different from each model, and but each the neuron for input data has a weight and bias, and actually you should know we have to define activation function and loss function, which is calculate the weight and bias of input data and transfer it to output for computing the output. And activation function and loss function is located in our hidden layer, and the main computation of a deep learning model is done in hidden layer. And actually the weight and bias are determined by minimizing the loss function through the gradient descent algorithm. And loss function, the general idea of gradient descent is to minimize a loss function. In deep learning, typically by its minimization, it is used to measure how our model is close to the ground truth. Ground truth, it means the real result of our model. The choice of the suitable loss function depends on the task that to be solved. And activation function, or also call it is called as a transfer function, defines how the weight, as I told, how the weight and bias is sum of the weight actually is transferred to output, and obtain the output through the neurons, which is located in the hidden layer. And the output layer, actually the activation function, which is defined for the hidden layer, is the same in all hidden layer, but for output layer it can be different, depend on the task that it can be that it will be done. And for example, for classification, maybe sometimes softmax is used, or sometimes you use sigmoid and different something. And the most important application and most popular activation function which is used in the deep learning are ReLU, Recliner, sigmoid, and tangent. And The loss function actually there are several loss functions for different tasks, but today I just want to talk about classification and regression, and with a supervised manner. And in this method, for loss function usually use for regression usually use mean absolute error or mean square error or root mean square error. And also for classification, we can use binary cross entropy, categorical cross entropy, and spur categorical cross entropy. And it is so important to know for in the classification task, if we have two class for output, we should use a binary class entropy, and our output, if our output is more than two class, we should use categorical or spur categorical cross entropy. And also for optimizer, we need to define optimizer in our model to optimize and minimize the loss function. And here you can see the most popular optimizer, which used in deep learning model: Adam, RMS, Prob, Nadam, and Momentum. And in this slide, I'm gonna talk about deep learning or deep neural network and convolutional neural network. And until here, you understand what the deep neural network is and how it works, and how can calculate how calculation is done in model. And but there is some difficulties and some sometimes we cannot actually use deep learning for our model. Assume that we want to use high resolution and high resolution picture with large size. Here we cannot use deep neural network anymore. Why? Because in neural network, neurons in each layer are fully connected, as you can see in picture, are fully connected to the neurons in the next layer. As the size of the image increases, the connection causes longer computational time. As a result, more powerful computing hardware is required. In addition, as you know, deep neural network works with in one-dimensional, or we can say work with in a vector. But convolutional neural network works with matrix, and we can use 2D matrix or 3D matrix, 3-dimensional or 2D dimension matrix in our convolutional model, and then use a flattener layer, convert the 2D or 3D features to 1D features, one-dimensional features vector, and use a fully connected layer, train our model, and then predict the output. As you can see, convolutional layer is made of 3 different layers, extracting the features. In extracting features, we can use max pooling or average pooling to increase and improve our model. And also after that, we use flatten layer to converts our features to a one-dimensional and vector, and then use fully connected layer. And also it is important to say, by converting, if we want to use neural network, deep neural network for high resolution or large image, you should know that converting an image to vector causes to loss of spatial information of the features. I mean that the network cannot recognize the positioning of a pixel or understand the significance of their locations. Because of that, we need to use another method like convolutional neural network to recognize the location and significance of the location and each pixel of our feature. And then by reducing this feature size and in each layer, and train our model in each layer, we can reduce the feature size and increase the depth of our model, so that we at the end of the convolutional layer we have 1D one-dimensional features with a deep depth, and then we use the flattened layer to transform to the fully connection. In convolutional layer, we use pixel neighborhood by computing the dot product method and using kernel. Each yellow square we call kernel, and we can extract a feature by using kernel and dot product operation between the kernel and the input features. Stride and padding are two hyperparameters that we need to define these hyperparameter for improving our model in the convolutional neural network. The resolution of our input model will be increased, and by using stride and padding, and also we can reduce the feature size by using and adjusting the amount of stride and padding. Actually, the result of the convolutional operation is a new matrix, and the dimension of the output or new matrix is highly depends on the padding and stride size. What the stride is? Stride means the length of the movement of these kernel. For example, here, as you can see, the red square is the initial kernel, and then the second one is this green one, and it moves by one cell. So here we have a stride by one, and as you can see, this is our input features, and this is output. When stride our input features is a matrix 5 by 5, but by using a stride 1, it becomes our output becomes 3 by 3, and as well as when we increase the amount of stride, our output size reduces. And also for padding, if we use we have two different padding, and valid padding and same padding. If we use valid padding, which is a default method for machine learning, the feature, the input feature, the input size of the feature will be decreases in the output. I mean, when we use valid padding, our output feature size is smaller than the input, as you can see in the picture. And if we don't want to do or obtain a smaller output feature size, we need to use same padding, and with using same padding, the input feature size is the same with the output feature size. How we can calculate the output feature size? Also, we can use this formula for calculating the feature size. N in means number of input features, and out means number of output features. K means convolutional kernel size. Here the kernel size is 3 by 3. P means convolutional padding. If we use valid padding, this will be 0, and if we use same, this will be 1 and becomes 2. And the last one is S, convolutional stride size. As you can see here, the kernel size is 3 by 3, the input size, the feature size is 5 by 5, and the stride is 1, and padding is 0. And by this formula, you can calculate the output feature size. So our input feature size was 5, and we don't have padding, so this is 0. Minus 3, kernel size is 3 minus 3 over divided by 1, stride was 1, so it becomes 1 plus it becomes 2 plus 1 becomes 3. So the output feature size will be 3, a matrix 3 by 3. And just this for stride and padding. And also yeah, as I said, if we want to prevent to shrink or reduce the output size, we need to use same padding. And another option that we can use in convolutional neural network, we can use pooling, max pooling or average pooling. The main goal of a pooling layer is to subsample to reduce dimensionality. As you can see, max pooling take the highest value from the area covered by the kernel, and average calculate the average or mean value from the area covered by kernel. The default value of kernel, which is defined in the machine learning or deep learning, is 2 by 2, and the stride is 2 by 2. And as you can see, this kernel covers this area and take 7 as a maximum number, and for this area 3 is the maximum number. But here as you can see, 7 plus 3 becomes 10, 12 divided by 4 becomes 3, and here we have a 3. Here we have 1, and also we have 4 here for this one. And in this slide, I'm going to talk about and explain about the different type of image processing. For image processing, we have four different categories: classification, semantic segmentation, object detection, and instance segmentation. What the classification and object detection are? Classification involves assigning label or categorize to images or a specific region. As you can see, in classification, just we can, for example, assign data to picture. We cannot make a boundary or detect the exact object and make a boundary for the object. But in object detection involves localizing and specifying objects within an image or video. It aims to identify a specific object of interest and provide their bounding box. As you can see, in object detection, we can detect and make a boundary for our object, and also we can make a label. But about the segmentation. Segmentation is the process of partitioning and partitioning an image or video into meaningful regions, or to identify and differentiate objects or regions of interest. It serves objectives, of course, such as understanding object boundaries, extracting fine-grained information, and enabling further analysis. As you can see, in semantic segmentation, we can just detect and determine two different things. For example, here we can predict, here we have another dog, and here we have sheep. But here there is a problem. What's the problem is? The problem is between we have three different sheeps, but our algorithm cannot detect these three sheeps that are different and predict all these three sheeps as a one part. But in instance segmentation, is a method which is is a combination of object detection and semantic segmentation. As you can see, in instance segmentation, we easily can detect the three sheeps as a three different part and three different objects, and make a boundary for each of them. For doing this kind of task, we have to make a mask for our input data set, training data set. We have to make a different mask for each model or each object, and then we can predict our object separately. But in semantic segmentation, we cannot, if we have, for example, one class, in this picture we have two classes, sheep and dog. We have two classes, and when we are masking or making a mask for our input data, we make it two different class. But semantic segmentation has a problem. The problem is cannot detect the different object of one class, and all of them put all of them in one part and one as a one object. Okay, until here we understand what the deep learning is, what the convolutional neural network is and how these algorithm work. Now I'm going to explain about a paper which it is done in 2023, and they predict a stress distribution around the whole of a part. As you can see, they generate random shaped or geometry of whole by Python code, and for creating the training or input data, they do the several simulation and make a mesh and use these data and these picture as a input picture. And also they use semantic segmentation method and activation function, which is used in paper was literally, and training data set, the amount of training data set was 900 and test data set was 100. And epochs means the iteration of in each layer for training convolutional layer, and they set 200 times. The optimizer method was Adam, and loss function method was mean square error, and batch size was 32 encoder. We have 6 blocks for encoder, and by max pooling 2 by 2 and decoding we also have 6 blocks for decoding or upsampling. In CNN we have different architecture for different tasks. For example, here you can see a unit CNN network structure, and in unit CNN structure we have two different sections. The first section is downsampling. We call it downsampling or encoder. In this section we decrease the image size and increase the depths of the features for improving and for training our model. And then in the second section that we call it upsampling or decoder, we use transpose convolutional matrix or layer, and for in this layer we increase the feature size and decrease the depth of feature, and finally we can get the output by the size of this with the same size of the input. And if our model our input data is gray or is not a colorful picture, we can use 1 as a depth or as a for gray picture, and if the picture are colorful, we have to use 3 instead of 1. And library which was used in this paper, TensorFlow and Cross, was TensorFlow and Cross. And the result was the loss function, and the result of the test loss and trained loss was so close to each other and almost 0. And as you can see, the prediction of model and the ground truth is quite the same, and we have a small amount of error in our model, and we can we can say this model is a reliable model. Also, they did a parametric study for this in this paper, and for example, in this figure, they investigate the influence of the number of trained data on the prediction. They, for example, train their model by 100 data, 500 data, and 900 data. As you can see, the accuracy of the model improves and increase when as the training data set increases. And as you can see in this picture, the prediction, the plot of the prediction, and the error decreases as the number of training data increases. And here in unit architecture for CNN, we have a interesting option that we call it a skip. What the skip is, for example, in this layer, we can extract or concatenate the output layer of this layer in the encoder section to the corresponding layer in the decoder section. This method can improve the accuracy and make our output a picture with a high resolution. Since we use a concatenated layer of encoder and transfer it to the corresponding layer in the decoder section, it causes to improve and increase the accuracy of model, and we prevent to lose the spatial dimension and information of our model. As you can see in the picture, the model with a skip connection has a good accuracy. The train and test data has a good accuracy, but without connection, the accuracy was not that good. And as you can see in the picture, the predicted figure was so near the grand truth, and the amount of error was so quite small, and we can figure out that we have to find a good and suitable architecture for our model. Okay, that's it for today. Thank you for being until end of this video with me, and I really appreciate it if you subscribe to my channel, and it would be a motivation for me to create this video for you guys. Thank you for watching this video, and don't forget to subscribe and hit the like button, and share with your friend. Thank you so much. I will come back soon.